polynomial and rational inequalities. When we're solving these inequalities, we'll be looking for solutions that make our polynomial either positive or negative. If the original problem is less than 0, then we are looking for negative results. If it's greater than 0, then we're looking for positive results. Also remember that for interval notation, if we have the equal to part on our less than or greater than, we'll be using brackets. And if it's just plain less than or greater than, we'll be using parentheses. So our first one says solve the polynomial inequality and graph on a number line. Write in interval notation. So this one's already factored for us. To start off, we're going to set each factor equal to 0 and solve. X plus 3 equals 0, x minus 5 equals 0, x is negative 3, x is 5. So these are the zeros from the graph. If we graph this, this is where our polynomial would cross the x-axis. So we need to see if our function is positive or negative all around those two zeros. So draw a number line and put these test numbers, or rather these zeros, on the number line, negative 3 and 5. Now we're going to pick test numbers around the negative 3 and 5. Write them smaller so that you'll know not to use those numbers in your actual final answer. So less than negative 3 could be negative 4. In between negative 3 and 5 is 0 would be easy to use. And then I need something bigger than 5, so let's do 6. So these smaller numbers will help us figure out the answer, but they're not going to be part of the answer. So keep that in mind. Now we're going to plug these test numbers one at a time into our factored x plus 3, x minus 5, and see if the result is positive or negative. So when I plug in negative 4 into the first parentheses, I have negative 4 plus 3, that's negative. So I just make a little note that that first parentheses comes out negative. When I put negative 4 into the second parentheses, negative 4 minus 5, that also comes out negative. So I make a note of that. And then I multiply. Negative times a negative is a positive. So I write a plus above the negative 4. Then I repeat with the 0. 0 into the first parentheses, 0 plus 3, that's positive. Into the second parentheses, 0 minus 5, that's negative. Positive times a negative is a negative. Plugging in the 6 into the first parentheses would come out positive. In the second parentheses would also come out positive. A positive times a positive is a positive. So I can see around my zeros if my graph is going to be positive or negative. Now look at the original inequality, and you can see it says greater than 0. If we're looking for things that are greater than 0, we're looking for the positive intervals. There are two of those on our number line. The first one runs from negative infinity. Well, I can't get that one to write, but negative infinity on the left to negative 3, this interval right here. And then on the right side, from 5 to positive infinity, it's positive. So those intervals would be negative infinity to negative 3, and I need a parentheses, not a bracket on the negative 3 because I don't have the equal to. And then also from left to right, 5 to positive infinity, and a union in the middle. Now for the next one, x plus 1 times x minus 7 less than or equal to 0. Set each parentheses equal to 0. X plus 1 equals 0. X minus 7 equals 0. So x is negative 1, x is 7. That's where the graph crosses the x-axis. So I make my number line, put the zeros on there, negative 1 and 7, and then I need some test numbers all around. So smaller than negative 1, maybe negative 2. In between, 0 is easy to use, and bigger would be 8. Those infinities on there. Now I'm going to plug those test numbers in one at a time back into the original problem. So when I plug a negative 2 into the first parentheses, my result is negative. And into the second, negative 2 minus 7, that's also going to be negative, and a negative times a negative is a positive. Plugging in the 0. First parentheses positive, second parentheses negative. Positive times a negative is a negative. Then the 8, both would be positive, and it comes out positive. Looking back at the original problem, it's less than or equal to 0. So I'm looking for the negatives, the negative intervals, and because I have an equal to, I know I'll be using brackets. So the section on my number line that's negative is right here in the middle. It starts at -1, it stops at 7, and because of the equal to part, I have brackets. So it's always from left to right, the start and the stop. This means if I graphed this polynomial, the part between x is -1 and 7 would be negative. That means it's under the x-axis. This one has not been factored for us. We'll have to factor it first. I look at the -6, and I know I want to get a +1 in the middle. So factors of -6, it would get me a +1, would be a +3, and a -2. So those are the two terms we set equal to 0. And solve, so x is -3, x is +2. Now make your number line and pick some test numbers. So -4, 0, and 3. Now plugging my test numbers in, -4, into the first parentheses would be negative, second one also negative, negative times a negative is a positive. The 0 plugged in, positive times a negative is a negative, and the 3 plugged in, both positive. Now just because all three of these examples went plus minus plus, that doesn't always happen. These just happen to turn out that way. It's greater than 0, that means I'm looking for the positive intervals. So there's one over here on the left and one on the right. From left to right, the first positive interval starts at -infinity, goes to -3. The second interval starts from left to right at 2 and goes to +infinity. I do not have the equal to on the original greater than symbol. That means all parentheses and a union because there's two parts. This one's already factored for us. They're both the same, so I only need to set one of them equal to 0. Add 1, divide by 3. So my 0 is at 1/3, so that's the only number I have to put on my number line. And then let's pick a number smaller and a number bigger. Plugging the 0 into the first parentheses would be negative. Into the second parentheses also negative. A negative times a negative is a positive. Then the 1. Plugging the 1 in, I would have a positive times a positive, which is also a positive. The original inequality is less than. That means I'm looking for the negative. Less than 0 is negative. Well, this number line doesn't have any negative sections on it, and so this one would be no solution. Now, the same basic concept is used to solve rational inequalities, which are fractions, but they do take just a little bit more work. So for this one, we want to set both the top and the bottom equal to 0. X plus 5 equals 0, x minus 2 equals 0, x equals -5, x equals +2. Now from the top, the -5, that's where the graph is going to cross the x-axis. But the 2 from the bottom would make the bottom be 0, and that would be a vertical asymptote. But there's still the places I have to look at on my number line. -5 and 2, and picking some test numbers. Let's do -6, 0, and 3. And on the top, plugging in the negative 6, I get a negative over the bottom. Negative 6 minus 2 is also negative, and negative divided by negative is a positive. The 0 on top would be positive, on the bottom would be negative. Positive divided by negative is negative. 3 on top is positive, on the bottom is also positive, so that interval is positive. Again, we have positive, negative, positive. I don't know what's up with that, but back to the original. Greater than 0 means the positive sections. So that's the one on the far left, the one on the far right. I don't have an equal to, so I know I need all parentheses from left to right. The first positive interval starts at negative infinity, stops at negative 5. Then the second one from left to right starts at 2, stops at infinity. So that's where that function would be positive, which means that's where it's above the x-axis. Okay, again, we're going to set both the top and bottom equal to 0. 3x plus 5 equals 0. 6 minus 2x equals 0. The one on the left, if I subtract 5, 3x equals negative 5, and divide, x is negative 5 thirds. On the right, subtract 6, negative 2x equals negative 6, and divide, x would be positive 3. So my number line, and picking test numbers, to the left of negative 5 thirds, that's negative 1 and 2 thirds. So let's do negative 2. Let's do 0 in the middle, 4 on the right. Plugging in our test numbers, negative 2 into the top would be negative. Negative 2 into the bottom would be positive. Negative divided by positive is a negative. 0 plugged in would be a positive over a positive, which is positive. And the 4 plugged in would be positive over a negative, which is negative. So this one actually turned out different. I am looking for greater than 0. I'm looking for the positive section. We have the equal to. That normally means bracket. But when you have a fraction, we have to worry about the denominator equaling 0, because that's not allowed. You can't divide by 0. So for the part of our answer that uses 3, which came from the bottom, and we can't let it equal 0, we're going to have to use a parentheses. It's not allowed to equal 0, and brackets signify equal to. So on these fractional ones, if it comes from the bottom, it is always a parentheses, because you're not allowed to equal 0 on the bottom. So if it comes from the bottom, it's always a parentheses. If it comes from the top, then it depends on if you have the equal to or not in the original. Okay, so my answer is going to be, I'm looking for the positive section, which is right here in the middle. It starts at negative 5 thirds, stops at 3. The negative 5 thirds came from the top, and there's an equal to on my greater than, so that's a bracket. But my 3 came from the bottom. It doesn't matter if I have an equal to or not. It's not allowed to equal 3 on the bottom, so it's a parentheses. X plus 5 over x plus 2 equals 0, so set the top equal to 0 and the bottom. Solving, x equals negative 5, x equals negative 2. And our number line, picking out test numbers, let's use negative 6. Negative 3 would work. Bigger than negative 2, 0 is easy to work with. Now plugging in the test values, negative 6 into the top would be negative. Same thing on the bottom, so it's positive. negative 3 plugged in. Top is positive, bottom is negative. That results in a negative. Both positive when you try 0. And the original says less than or equal to 0. That's negative. And it has the equal to again, but remember, if it comes from the bottom, it is always parentheses, even if the original has an equal to. The negative section is right here in the middle. From left to right, it starts at negative 5, stops at 2. Negative 5 comes from the top, so because of the equal to, it will have a bracket. 2 comes from the bottom, or it's a negative 2. If it comes from the bottom, it always has a parentheses.